I will talk about typing in R. Let me open a terminal. And our topic is typing in R. So we use library Tidyverse for this topic. And actually the pipe operator comes from the magritar package. Here is our typing operator. And we just called it as typing operator. Let me write it here. Typing operator. This guy. And for this guy, actually it is in the library of magritar. And also Tidyverse has that operator and automatically loads it for you. You can just use some of them, but if you are already using Tidyverse, just go with that guy. And if you are familiar with the bash or terminal or any terminal programs like SSH or bash or zch, please remember that the pipe operator was this guy. Okay. And also, if you are familiar with ggplot, plus is the pipe operator with similar purpose of usage of this guy. And piping allows us to pass result on to the next functions without storing the intermediate results in here. And so we use that pipe operator to write code in a way that is easier to read and understand. But it's up to you guys. It's depending on your personal proficiency in programming. Let's start with an example. Let me first say this one, like piping. Okay. And we will use the data tips for this example in the package of reshape2. Here is the data set we will use. We want to see some line of the data, and we can just use head comment in here. You see that in this data set, we have total bill, tip, gender, smoker, day, time, size. And so for this data set, we can just write tips and use that piping operator. And so I will use tips. I'm going to subset this data set and by the total bill variable if it is greater than 19. Okay. And again, I will just use piping operator in here to aggregate the results depending on this subsetting. And I want to aggregate everything by gender in here, and we will just find the mean value. Okay. So what is happening in here is that we use tips, and this is input, and you are going to use that input in here in tips, and the output of this subsetting is going to be the input of your next line. Okay. So piping operator is just connecting these two comments, and the output of this, the comment on the left hand side is going to be the input for the next one. When you just run this part, and you see that we are able to get subsetting the data by the ones that total bill is greater than 19, and we aggregate the data by gender in here, and each of them now, each of these numbers are showing the mean values for us. Okay, and we can just do that. And so as a summation, what we did in that code chunk is that we take the tips data, subset the data, and aggregate the data. And you can even change that function in here. Instead of mean, we can just write maximum value. And let's say I'm looking for day, okay, this time. And when you check about your result, this time we are aggregating by day. You see that we have Friday, Saturday, Sunday, and Thursday. And when you just do str tips, you see that we have day as a factor with 4 levels. And now we are able to aggregate of our data by day in here, just using this piping operator. And we get all these maximum values for day in here. And for the next example, let's generate a vector from normal distribution. I want to just generate a vector from normal distribution, let's say with 10 of them. I want to save them in an object. This is how we are doing that in R. And take the absolute values for this one, absolute value of all of them. And I want to just save it in here to A1. And then we want to get the logarithms of the values in that vector. Let's say I want to just get the log of A1. But this time, again, I'm just giving a new value and just save it in here. And also, as a last step, we want to round my random variables, which are saved in A2, and round it to 1. And I want to save it to somewhere, A3. And when you just A3, you can find your result in that object. So what kind of problem does it cost? I want you to think about this part. We are just finding, we are just using several objects in here by these comments. And so I want you to concentrate on the problems cost in this code chunk in here. So the first one can be the code is cluttered with unimportant names. You have lots of names in here. And when you just start writing R codes, you will see that you will need lots of names. And when you just use a lot of them, then your code is going to be kind of confused and it's not easy to remember the names in there. And also you have to carefully increment the suffix on each line in here, okay? Instead of doing that, we can just overwrite the original object. Let's see. So if you don't need that internal steps, you can just override it. I'm going to generate normal distribution vector in here. And also I want to get the absolute values of that A. And again, I want to just get log of A. And then I want to just round my A to 1, okay? So we can just overwrite them and find our A as a last step and just use less names in here. You have lots of names in here, but we only have one in that code chunk. We can just overwrite them. But what kind of problems does it cost? I want you to concentrate on that part. So what happens is that debugging is kind of painful. So for example, if you make a mistake in somewhere between these code chunks, you will need to rerun the complete pipeline from the beginning, okay? And also the repetition of the object being transformed obscures what's changing on each line. So instead of doing that, you can just nest that parenthesis for the same example. Let's say I want to solve that problems now. We can again generate a object from 10 normal random numbers. Here are my A's. Now this time I can just use nested parentheses. So we have round. I'm going to round off log of absolute value of A to, it's going to be 1. I'm going to round to 1 in here. You see that? Now, instead of using lots of names and just use the same name several times, we can just use nested parentheses. And this is kind of much easier to read and also track for you, okay? So instead of this one, we can also use piping in the same example and just make it more clear to read. Let's say I want to assign the result of my calculation to the object, not object this time. Let's say I have my A, okay, and I want to just add a piping in here, get the absolute value, okay. And again, I want to use that piping. And please remember, the second thing we were doing is that we were just getting the log value, and then I'm piping to rounds to 1. Okay, this time we are using piping in the same example, and we have our results. And this is our result in here. But when you just check out for A, you have the original values. That's something good for us. And you may do not want to save the values onto A, just you want to keep the original values for A in here. But also, if you want to assign the results of your calculations to the object, you can use compound asymmetry operator in here. Here is what I mean. I have my piping operator, and if I add smaller sign in here, this is my compound assignment operator. And let's see how it is working. Let's first remember this part. I have my A, and I'm just using piping for my codes in here. But this time, let's run this part one more time. But this time, instead of this piping, I'm just using compound assignment operator. Okay, here's what I'm doing. When I run this part, you will see that it's just not giving me the results because the result is saved in A. Okay, we just assign the results of our calculations to the object this time. So for the functions with more than one arguments, the function can be written like that. So I can have my first argument, this is the first one, and I can add my function. Here is my function, and here is my second argument. Okay. And this is how I can use piping for more than one arguments in a function. I write the first argument in here, and I write my second argument in here. Let's just comment. And let me give an example. I have my A again. And let's say I have normal random variables like 15. And here is my A. And I'm just rounding A to 2. Here is my A. And so with piping, how it was working, that A and pipe it and round 2. Okay, and here is my result in here. I have my, you see that I have my first argument here, like the example, like in the example, and I have my function which is round, and my second argument in here is there. Okay. There's something about pipe is that it's sometimes not working for some classes of functions because some functions use current environment. So for example, when you use assign, this guy, here is my function, which is an example in here. If I'm using that assign function, it just creates a new variable with the given name in the current environment. Let's see what I mean. Let me just show you with an example. I have my assign, and I'm going to assign pi value to my A. Please remember, here is my A. And now I want to assign pi to my A. And when I assign it, you write that, you see that now it is pi. And you can use it like that. Let's say you want to use it with a pipe operator. How can you do that? You should first write your first argument and add your piping, and then add your assign, And now you can assign 20 to A. Okay, this is how I can just write this part. Instead of pi, I'm just writing 20. And this is how I can just convert this command to piping. Okay, and when I write it, you see that A is not 20, it is still pi. I was not able to assign that my 20 to A in here. So please notice that A is not updated with that piping. Because in here, my function assigns the new value to a temporary environment by this piping. When I use piping, my new value is just goes to that temporary environment in there. Okay, but of course we can solve this problem. R wants us to be explicit about the environment. So if you want to use that assign function in here, we can first define our environment. Here is my environment. I just define it. Okay, when you see it, I'm just using my global environment in here. Now this time, if you want to use piping in here, so we have A, I have my piping, I'm going to use assign 20. So I should just give the environment in here. Then it is going to work. When I say A, now I was able to assign that value to A by using assign function and giving environment. And please keep in mind that get and load functions are working at the same way, and then you should just add environment in there, okay? So if you are working with more complex part, it's sometimes useful to call a function for its side effects, okay? Maybe you want to print out the current object and or plot it or save it to disk. So many times such functions don't return anything and effectively terminating the pipe in here. If we want to solve that problem, we can use T-pipe. Here is our T-pipe. Let's add pipe and you just add T in here. This is your T-pipe. And if you only have tidyverse, I think this T-pipe is not working there. So you should also load your Margaret tar to work this T-pipe in here. So this T-pipe just work our original pipe sign, except that it returns the left-hand side instead of the right-hand side. And it's called T because it's like a literal T-shaped pipe. Let's see what I mean. Let me just a comment in here. And here is my example. I'm generating random numbers from normal distribution and piping that numbers and just generate matrix from these numbers with 2 columns, okay? I'm just starting with a piping example, then I will just change it to T pipe. And let's say you want to plot the result. And also you want to use that str, okay? Here is what I'm trying. I'm generating 10 random numbers from normal distribution. And the output is going to be used as a matrix with 2 columns. And the two columns will be plotted. And I'm also asking the structure of this data. When I run this part, you will see that, okay, I'm able to plot my numbers in here, my matrix. Here is my plot in here. But the result of str is a null value. Okay, so it's not working like that in here. So for this example, so instead of that piping, I can just use T-pipe. Let's see what I mean. Here is the same example. Now this time I'm just adding T, and it's going to use this left-hand side instead of the right-hand side in here, okay? And let's see, so after that, after this part, it's always using this left-hand side for the rest of the commands. When I run this guy, now you see that it's working with plots, but also I have my str result, okay? Because it's using the left-hand side in here, And so now we are able to use that one. Okay. And I want to also give another piping example in R. Let's say I have this guy. It's kind of different now. And we have $sign and this one. This is another piping example. So if you are using individual vectors in a data frame, this piping might be useful to evaluate in the context of that data frame. Let's see what I mean. Let me comment this one. I have empty cars and I'm piping it. And I want to just get correlation of display and MPG. In here, instead of piping, that piping, our new piping is going to be working. So now it is good to work the vectors in your data frames with this piping in here. Okay. And we can also use placeholders, which is dot. Dot is the placeholder in R. We can use that guy for attributes once or several times. Let's see what I mean. Let's see. So let me write placeholder. And I have, let's say I want to do rounding, like the round of pi, p I mean. Here is 3. And I'm going to just add piping. I want to round my pi to dot. Okay, this is placeholder. When you just write something in here, it's going to know that it will just go there and just get 3 in here. And what does it mean that this is just rounding pi by 3? Okay. And here is the same job. You see that? Let's see another example. And we are going to initialize a matrix by using matrix function. Let's say I'm just going to generate my matrix from 1 to 12. Let's say here are the dimensions for my matrix. If you want to see that guy, here is the result. I have my matrix now. So let's find the maximum of the values inputted in here. So I have my matrix. I'm just piping it. And I want to get the maximum value of these two guys. So number of rows of my matrix. So number of columns. Sorry. No, columns of my matrix. What is happening in here? I'm using my matrix and just ask for the maximum value for some of them, okay? This is just an example. And 12 is the maximum value in everywhere in this matrix. Or you can just say my matrix and, oh, sorry guys. I have M. I'm using Shift Command M as a shortcut for piping. And Shift Control M is also used in Windows for shortcut of this piping in here. And my matrix max, and instead of using that, I can just use the placeholder and it's giving me the same result in here. Okay. And we can also use assignment operator. Maybe you remember, here is our assignment operator. We use a lot, like this one. We can also combine this guy with piping in R. Let's see my tips data again. I want to use my tips data. And let's say I want to generate a new value in this data set. Okay. So I can just assign something in there. Here is my tips. I want to use total bill and just add piping in here. You just find the square root. So what is happening in here? We are just finding the square root of this total bill and just assign that value to my new value in tips data. And yeah, we do that. And if you want to see your data set, now we have a new column this time. We assign this value by the square root of total bill in here. This is what I wanted to say about piping in R for today. And here is the reference I used to prepare this video.